All right, guys, so the last webinar that we discussed the distance formula. It's this crazy looking formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, in this video, I'm going to give you a little insight that, you know what, we did not make up this formula. This formula has been passed down years and years and years and years and years ago, okay? And the person that you can blame is Mr. Pythagoras himself, okay? That name may sound familiar to you. He did come up with a famous formula, the Pythagorean theorem. So just in case if you did not remember that, let's go ahead and jot that down real quick, because we're going to actually use this to prove our distance formula and show you where does this actually come from. Pythagorean theorem, remember, is given a right triangle, you can take the square of the legs, okay, the sum of the squares of the legs, excuse me, and set that equal to c squared, or the hypotenuse squared, okay? So let's just assume for a moment we're given 2 points. You're given a regular problem like this, okay? And I want you to calculate the distance between this, okay? So this is what we have right now. Okay, so I'm going to just label this generic point here as x1 and y1. We've used that before when we were talking about slope. Okay, this one I'm just going to call this x2, y2. All right, and if we're going to talk about Pythagorean theorem, the trick behind Pythagorean theorem, okay, because I want you to make sure that you understand some of these principles for proving the distance formula, we need a right triangle. So I'm going to take these 2 points and form a right triangle with them. So I'm just going to follow the grid lines until both of these points actually meet. Okay, and I'm going to make this a new point. Okay, now this new point right here encompasses x2, this x2 right here, because we're using that point right there, and the y1. Okay, so we've got our 3 points in place. This is a right triangle, so I'm going to put that little box in there. Okay, so we're trying, our goal ultimately is to figure out how can we get the formula from this right triangle. All right, now if I look at this right here, this line right here, well, if I'm looking at the y values, because this is running up and down, okay, and if I want the distance of this, well, do you agree that it's just the difference between this coordinate to this coordinate? So this is actually just y2 minus y1, okay? This one down here is just the difference between x2 and x1. All right? So remember, these things on a right triangle, these sides, this side and this side, are our legs, okay? That's actually technically our A and our B. Okay, so remember, these are the legs of the right triangle, all right? Now, if we kind of match this up with the Pythagorean theorem, I'm going to call this leg down here A, this leg B, and then this hypotenuse, this diagonal line right here, we're going to call that C. And remember, C is what we're looking for. We're looking for that distance, okay? So let's apply the Pythagorean theorem and watch how we get the distance formula, okay? So if I take the A, which is x2 minus x1, and square it, okay, plus the B, which is y2 minus y1 squared, okay? Remember, that is going to be equal to the hypotenuse, which in this case is c to the second power, c squared. Oops. All right, now, I don't want just c squared. I want little old plain old c. So in order to get a c by itself here, I'm going to square root both sides. Okay, and if I square root that, I'm just left with a c. And what do you see in front of you? Yes, the distance formula. So again, just make it nice and pretty. Square root of x2 minus x1 squared plus y2 minus y1 squared is equal to c. Okay? So in a few moments, I'm going to show you an example where we're going to actually use the formula to solve this. And I'm going to show you, if we use Pythagorean theorem to prove this, couldn't we use Pythagorean theorem to solve for the distance? Okay, so we're going to look at an application right now. We're going to look at a problem. Okay, so suppose that we have this problem in front of us. All right. And the directions say what's the length of the segment EF. Okay. Well, we're going to do a traditional style and apply our formula. Okay. So first of all, the coordinates of E is what? Let's see, that is -4, -5. Okay. And then our F is 5, 2. Okay. And so let's calculate the distance actually using the distance formula. Remember, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. And so if it helps you, you may have already kicked the habit already, but if not, you can just label all these points. xy, xy. Okay. 1, 1, 2, 2. Entirely up to you at this point if you're comfortable with that. So D is equal to, let's go ahead and substitute in our values. x2 is 5 minus x1, which is a -4 squared, plus y2, which is 2, minus -5 squared. Okay, so when you clean this up here, I see a negative and a negative, that makes positive. 5 plus 4 is 9. 9 to the second power is 81. Okay, plus another double negative here, so make those positives. 2 plus 5 is 7. 7 to the second power is 49. And 81 plus 49 gives us the square root of 130. Okay, which, aren't they nice here? They actually give you answer choices here. So the answer would be B, of course, 130. But by applying the formula, we get the square root of 130. All right, that's good. Now, this other way, how could I use Pythagorean theorem to get the same answer? Okay, and you may really like this, and if you enjoy this, there's absolutely no problem in using this method at all. Okay, first of all, what did I do in my proof? I took a plain old line segment and I created a right triangle. That's step number 1. Pythagorean theorem equals a right triangle. So I'm just going to connect this using the grid lines, like so. Okay, and I'm going to count now the distance of this straight line. Okay, so let's see how many points this is. This is 1, 2, 3, 4, 5, 6, 7. So this consists of 7 units. Okay, and then I'm going to count this length right here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. And of course, I have no idea what this is over here, so I'll just call this C. I want that distance. Okay? Now, by applying old school Pythagorean theorem, it says I should be able to take the square of the sums of the legs and set that equal to the hypotenuse. Okay? The square of the hypotenuse, that is. So here we go. 9 squared plus 7 squared should be equal to C squared. 9 squared is 81. Hey, I'm starting to see some numbers here from when I actually did all the algebra. Plus 49 equals C squared. 81 plus 49 is 130. Is equal to C squared. But do we want C squared? No, we want plain old C. So I'm going to square root both sides. And you can see now that we get the square root of 130. Same thing that we got when we worked out the distance formula. Again, the choice is yours. If you like this idea of creating a right triangle and using the Pythagorean theorem to solve, do it. Not a problem. If you're just a old school type of person and you like to use the formula, use that as well. Both of them, as you can see, are equivalent. And that's it for this. Of course, go ahead and practice your homework, which is to practice more distance problems. And that's it. Thanks again for listening.